Okay, Chuck, this video is for you. Hopefully you can hear it well and the video quality is good. I wanted to help you out by going through how to install the 50 amp PWM you got from HHo connection. This is the exact one, and also show you how to install. This is the Harbor Freight style amp gauge. Basically, the high current power goes through this gauge, so you don't use any shunts or anything like that I was telling you about. And I've got the cell here. It's filled with water. There's the tank there. And I want to try to answer your question about why you're only getting 20 amps pull with 20 teaspoons of KOH. And you're right about volts driving the cell, and I'll show you why that's right. So what we got here first is I've got a power input. This is my positive power input, so this could be coming from the battery per se, and here's my negative going back to the battery or to the vehicle ground. The project's being powered by this power supply, so we'll just act like that's the alternator and the battery and the whole system. So the first thing you want to do is, on your positive side, this is where you hook in your relay. So you come in from your battery on the relay, and then out on the big terminals, high current terminals, and out to the cell. Now your circuit breaker is also in the positive side. You actually can install this in the negative side if you want. Doesn't matter where this is in the actual circuit. When it senses 60 amp or above, it'll trip. I like to put them in the positive side. So you can run your power from your battery into this, out of this, to the relay, and then out of the relay to the positive terminal of the cell. To energize, might as well go over this. To energize the relay, you simply go from a power input here on the, so this is how it goes, a power input here, and then an output to ground, chassis ground, battery ground, anywhere you want to hook up a ground. And this can be in on a smaller wire, say like a 14 gauge wire, or even 16 gauges. Doesn't take much current to close this solenoid. So that's why you come off your fuel pump relay or oil sending unit into this terminal here. That way this whole system will only be on when the HHo, or when the engine is running. So that's that part. Now we'll go ahead and I'll show you how to hook up the PWM. Okay, so we've hooked up our solenoid, our circuit breaker, and we're coming from our positive to the positive terminal of the cell. I usually go on the right side, just fine. If it's on the left, it's fine. So we'll hook that up. First thing to hook up. And the negative going to the body ground or back to the battery is going to hook up to the ground terminal here on the PWM. Hook that up. Okay, now the board inside here needs a little bit of power, positive power, so you need to bring a positive wire from, I like to bring it from the cell, or you can bring it from the relay. Just put it on the side of the relay that's actually turns on when the relay is closed. That'll turn on the cell. For this demonstration, I'm going to put it right here on the positive terminal. That way we're getting, and this here it could be a low gauged wire. It could be as low as 16 gauge wire, because the board, it just needs a little bit of power to function, and it also goes to the fan and the PWM. So in this case I've got, this is a 10 gauge, but it's overkill. Now this one goes to the, this is 12 volt VDC, goes right there. That's going to power the board. Okay, now your amp meter, I've got it pre-wired here, in and out. And it goes on the negative side of the circuit. So what I like to do is put it in between the PWM and the negative terminal of the cell. Here it says 2 cell negative. You're going to hook your negative wire right up there, and that's going to go through the amp gauge and give you a reading directly on the amp gauge, and then into the cell to complete the circuit. Okay, so that's the whole circuit. Everything's hooked up. Now we just turn it on. So I got it on there. And of course you control the amperage. So I can bring this up here a little bit. The wires aren't that flexible. There we go. Now you can see how the gauge moves over into the positive. Like that, sort of pulling about 22 amps, somewhere in there, on this little cell. This is a 24 plate cell. Let's see what else. Okay, your engineer. The reason why you can't pull over 20 amps is I'm looking at your setup here in the pictures, and you're driving the system off of a 12 volt battery. You're driving the system off a 12 volt battery, and the most a 12 volt battery can give you at max is just a few tenths of a volt over 12 volt, if that. The cell that you bought, the 31 plate cell, and all the cells that I have are designed to run on a car charging system. And a car charging system is between 13.5 to 14.2 or 3 volts. So even the difference of a 1 volt or 1.2 volts will make the difference from the cell producing. And I'll demonstrate that here. Find a meter here that works. There we go. Okay, so this meter I'll hook up. Okay, I'll hook the black lead to the negative side and the positive lead to the positive side of the cell. And set the, here we go. Okay, right now the cell is drawing 13.46 volts. And you can see on the gauge, I hope there's not a glare, the gauge is somewhere in the 20 amp range. Now I've got a variable voltage control on my power supply. Look what happens to the amperage when I turn the volts down to 12 volts. Now it's moving down right there. 12 volts. So if your battery is actually at 12 volts with a full charge on it, you can see that the amp gauge now is about 3 amps. So that's the difference, and that's why you're not getting an amp draw. Right there you can see 3.4, 3.5 amps. And as I turn this up to 13, highest I can get right now is 13.4, but if you can imagine at 13.8 volts that the amperage draw would even be higher. So yeah, it's pulling about 16.6 at 13.4 volts. So the closer you get to 14, the higher the amperage is going to get. So that's going to take care of your problem. If you want to go ahead and take your system that you have here in the picture and bring a car over, your truck over, whatever, and take some jumper cables and hook them to that battery, you'll see a spike in your amperage. Now, 20 teaspoons per 2 liters of distilled water is a little too high for the 31 plate cell and that PWM you bought. You want to get it down to about 8 to 10 teaspoons per 2 liters, and the whole system should run just the way you want it to. Adding just a little bit more KOH if you want to bring the amperage up. Alright, I hope this video helped you out, and appreciate all your sharing with me of your project, and that's the end of the video. Thanks for watching.